Hey guys, welcome back to my channel. Today we're going to do IAL Edexcel International Advanced Level Maths Paper 4 for June 2024. In this video, we'll go through all of the questions that came in Paper 4 and see how difficult or easy this paper was overall. So let's start with this one. So in this question, it says you must show all stages of a breaking. Solutions relying entirely on calculator technology are not acceptable. So we have to find the integral of x times cos 3x dx from the limit of 0 to pi by 6, giving your answer in simplest form. So for this, we're going to use integration by parts. So based on integration by parts, x is going to be u, and cos 3x is going to be dv. Because integration by parts is that integral of x, because according to integration by parts, integral of u dv equals to u times v minus the integral of v du. Hence, u is x and cos 3x is dv. So we differentiate u with respect to x. So u equals to x, so du over dx is going to equal to 1, which means du equals to dx. Over here for dv, which is equal to cos 3x, we're going to integrate both sides. That's going to be v equals to sine 3x divided by 3. That's the integral of cos 3x. Now we're going to substitute these values in the formula. So integral of x cos 3x dx equals to x times sine of 3x over 3 minus the integral of sine of 3x over 3, and we replace du with dx. And this is from 0 to pi by 6. So let's add the limits as well. So x sine 3x over 3. Now we integrate sine 3x over 3, which is going to be negative cos 3x over 3 minus negative cos 3x over 3, and again times 1 over 3 from the previous 3. And this is from 0 to pi by 6. Let's simplify this. X sine 3x over 3 plus cos 3x over 9. Now we're going to put in the values. So first you put the maximum value, which is pi by 6. Pi by 6 times sine of pi by 6 times 1 over 3 plus cos of 3 times pi by 6 times 1 over 9 minus 0 plus cos of 3 times 0 over 9. So we solve the first bracket. What we get is pi by 18. Just plug it in the calculator and you'll have your value. And for the second bracket, we're going to get minus 1 over 9. So they want the answer in simplest form. So this is your answer. Pi by 18 minus 1 over 9. That's the integral. Then says with respect to fixed origin O, the point A has a position vector OA, which is 7, 2, negative 5. Given that AB is negative 2, 4, and 3, we have to find the coordinates of the point P. So to find the coordinates of point P, AB is basically AO plus OB. We're going from A to B, so we go from A to it and O to B. We have to find the coordinates of OB. So OB is going to be AB minus AO. AB is given as -2, 4, and 3. And AO is going to be the opposite of OA. Basically, we change the signs. So that's going to be -7, -2, +5. When we subtract them, what we get is -2 plus 7 is 5, 4 plus 2 is 6, 3 minus 5 is -2. This is your position vector for B. They want the coordinates, you can write it as the vector as well, or write it as a coordinate. That's your answer. Then the point C has position vector. Then the point C has position vector OC, which is A, 5, and -1, where A is a constant. Given that OC is perpendicular to BC, find the possible values of A. So we have the vector for OC. We can use that with A. We can use that and OB to find BC. And then when it says that two vectors are perpendicular, that means the dot product of those two vectors is, going to be equal to 0. So let's begin with finding vector BC first, and then we use the dot product. So BC is going to be OC minus OB. So OC is given the question as A, 5, and -1. We just found OB, which is 5, 6, and -2. That's going to be A minus 5, -1, and +1. Now we're going to find the dot product of BC and OC. And that is going to equal to 0. So A minus 5, -1, +1 times A, 5, and -1. So it's going to be A times A minus 5 plus 5 times -1 plus 1 times -1 equals to 0. That's A square minus 5A minus 5 minus 1 equals to 0. Collect the like terms. A square minus 5A minus 6 equals to 0. Now we factorize this quadratic equation to find the possible values of A. So A squared minus 6A plus A minus 6 equals to 0. A bracket A minus 6 plus 1 bracket A minus 6 equals to 0. A minus 6 bracket A plus 1. So we can see that one value of A is 6 and the other is -1. That's your answer. And so the curve C is defined by the equation 8x cubed minus 3y squared plus 2xy equals to 9. Find an equation of the normal to C at the point 2, 5, giving an answer in the form of ax plus by plus c equals to 0, where a, b, and c are integers. So this is a part of differential equations. So we're going to differentiate this. 8x cubed minus 3y squared plus 2xy equals to 9. So derivative of 8x cubed is going to be 24x squared. 3y squared is going to be 6y and then times dy by dx. everything is going to be differentiated with respect to x. So we know x differentiated with respect to x is going to be dx by dx. So that's why we don't write dx by dx because that equals to 1. But for y differentiated with respect to x is going to be dy by dx. And over here, two variables are being multiplied, so we're going to use the product rule. So plus 2 bracket derivative of x is 1, so 1 times y plus x times derivative of y, which is dy by dx, and constant becomes 0. So 24x squared minus 6y dy by dx plus 2y plus 2x times dy by dx equals to 0. Now we're going to make dy by dx a subject because that's going to give us the gradient of the equation. So let's isolate dy by dx on one side, everything else on the other side. So 24x squared plus 2y equals to 6y times dy by dx minus 2x times dy by dx. Take dy by dx common. That's 6y minus 2x over here. And then we're going to divide 24x squared plus 2y by 6y minus 2x. That's your dy by dx. Next, they already gave us a point on the curve through which the normal is passing. So we're going to use 0.25. So we're going to use 0.25 to find the gradient. So 24 times 2 squared plus 2 times 5 over 6 times 5 minus 2 times 2. That's going to give us a value of 106 over 26, which we can simplify to 53 over 30. Now this is gradient of the curve. So for gradient of the norm, we're going to flip it and make it negative. Why? Because they're both perpendicular. Going to be negative 13 over 53. We have the point, we have the gradient, we're going to find the equation now. So y minus 5 equals to negative 13 over 53 times x minus 2. 53y minus 265 equals to negative 13x plus 26. That's going to be 53y plus 13x minus 291 equals to 0. That is your equation. And figure 1 shows a sketch of a segment PQRP of a circle with center O and radius 5 centimeter. Given that angle POR is theta radians, theta is increasing from 0 to pi at a constant rate of 0.1 radians per second. The area of the segment is PQRP, which is a centimeter square. We have to show that dA by d theta is equal to k times 1 minus cos theta, where k is a constant to be found. So for the area, which is area of the segment PQRP, this is this segment. We find area of the sector, then we find area of the triangle ORP, subtract the two, that gives us the shaded part. So area of sector, since we're talking about radians, we're going to use the formula 1 over 2 r squared theta. R is 5 times theta. So that's 25 over 2 theta. Then area of triangle, that's 1 over 2 times 5 square times sine theta. That's 25 over 2 sine theta. So A is going to be 25 over 2 theta minus 25 over 2 sine theta. So now we're going to differentiate this. It's going to be 25 over 2 minus 25 over 2 times cos theta, because sine theta becomes cos theta when we differentiate it. So next we're going to take the 25 over 2 common. It's going to be 1 minus cos theta in the bracket, which is the exact same format as given the question, which was k times 1 minus cos theta. So k is 25 over 2. Then find in centimeter square per second the rate of increase of the area of the segment when theta is pi by 3. So for this now, find the value of dA by d theta first when theta is pi by 3. That's 25 over 4. We have the value of d theta by dt, which is 0.1. So to find dA by dt, that's dA by d theta times d theta by dt. 25 over 4 times 0.1, which gives us a value of 5 over 8 centimeters square per second. That is the answer. And it says figure 2 shows a sketch of the curve defined by the parametric equations x equals to t squared plus 2t and y equals to 2 over t times 3 minus t, where t is between a and b. A and b are constants. The ends of the curve line on the line with the equation y equals to 1. So you can see that it's ending at y equals to 1. Find the value of a and the value of b. So to find the value of a and b, we can easily put y equals to 2 over t times 3 minus t equal to 1. Why? Because like y equals to 1 line lies on the curve because it's passing through it. So if we put y equals to 1 in the second equation, we can get the value of t. So y equals to 2 over t times 3 minus t, and y is 1. So 2 over t times 3 minus t, cross multiply, t times 3 minus t equals to 2. 3t minus t square equals to 2. Bring everything on the right hand side. T square minus 3t plus 2. Now we factorize this. T square minus 2t minus t plus 2. T bracket t minus 2 minus 1 bracket t minus 2. T minus 2 times t minus 1. T equals to 2 and t equals to 1. So b is 2 and a is 1. These are your values. Then it says that the region R shown shaded in figure 2 is bounded by the curve and the line with the equation y equals to 1. Show that the area of region R is given by m minus k integral of t plus 1 over t times 3 minus t dt, where m and k are constants to be found. So first what we'll do is, we know that area is basically the integral of y with respect to dx, okay? But over here, we have y in terms of t and x in terms of t. So let's use x equals to t squared plus 2t to find dx by dt. Because when you replace y with t, you can't integrate when there's dx over here. We need dt over here. For that, we have to differentiate x with respect to dt and then replace the dx with dt. So this is going to be 2t plus 2 and dx is going to be 2t plus 2 times dt. So now area is going to be integral of y times 2t plus 2 times dt, and we have a limit from 1 to 2 for t. So now we're going to replace the y with its expression, which was 2 over t times 3 minus t. And then over here we have 2t plus 2 times dt. So what we can do is over here, between 2t and 2, we have 2 commons. If we take 2 commons, it's going to be 2 times 2 times t plus 1 over t times 3 minus t dt, 1 to 2. That's going to be 4 outside, and integral of t plus 1 over t times 3 minus t dt. Now if we go back to the question, it said, show that the area of region R is given by m minus k times this integral. So we have the k down, we have the integral down. What's missing is m. So if we go to the diagram, area under the curve is basically this part. But since the shaded part is this part over here, so we find area of this rectangle first and then subtract the area under the curve to find the region R. So for the rectangle with the dimensions, we know this distance is 1, but we don't know what this distance is. And to find this distance, what we do is we put t equals to 1 and t equals to 2 in the x equation to find the x value, and then subtract those to find the other dimensions. So basically, x is t squared plus 2t. So put t equals to 1. That's going to be x equals to 1 squared plus 2 times 1, which is 3. Then we put t equals to 2. That x equals to 2 squared plus 2 times 2, which equals to 8. So R is going to be 1 times 8 minus 3 minus 4 integral from 1 to 2 and then t plus 1 over t times 3 minus t dt, which is 5. So 5 minus 4 integral from 1 to 2 and then we write the fraction. That is your final answer. Then it says, write t plus 1 over t times 3 minus t in partial fraction. Then it says use algebraic integration to find the exact area of R, giving the answer in simplest form. So for C1, first let's convert this into partial fraction. It's going to be A over T plus B over 3 minus T. So we're going to cross multiply and get rid of fractions. So T plus 1 equals to A times 3 minus T plus B times T. Expand the bracket. 3A minus TA plus BT. So quotients of T on both sides will be put equal to each other and the constants will be put equal to each other. 1 equals to 3A, which means 1 over 3 is equal to A. 1 equals to negative A plus B. So 1 equals to negative 1 over 3 plus B. 1 plus 1 over 3 equals to B. That's going to be 4 over 3. So your partial fraction is going to be 1 over 3t plus 4 over 3 minus t. That's a partial fraction. Now we're going to integrate this. Five minus 4 integral of 1 over 3t plus 4 over 3 times 3 minus t from 1 to 2 dt. This is the same as the initial expression, so we're just replacing with this so that it's easy to integrate. So 5 minus 4, 1 over 3t becomes 1 over 3 ln t plus negative 4 over 3 times ln 3 minus t from 1 to 2. The reason why 4 over 3 becomes negative is that because we're differentiating the t in the bracket. So derivative of negative t is negative 1. So that's why we're multiplying negative 1 and 4 over 3. And the bracket then goes with ln. So now we're just going to put the limits. Ln 2 minus 4 over 3 ln 1 then minus 1 over 3 ln 1 minus 4 over 3 ln 2. Five minus 4 bracket 5 over 3 ln 2 and minus 5 over 3 ln 1. So 5 minus 20 over 3 ln 2 over 1. We're combining the ln's. When they're being subtracted, you can divide them. So 5 minus 20 over 3 ln 2. That is your answer. First, I took the 5 over 3 common outside, so it became 20 over 3. Then ln 2 minus ln 1 is the same as ln of 2 divided by 1, which gave us ln 2. So the final answer becomes 5 minus 20 over 3 ln 2. That's the region R. That's the area of region R. Then it says with respect to a fixed origin O, the line L1 is given by the equation R equals to I plus 2j plus 5k plus lambda times 8I minus j plus 4k, where lambda is a scalar parameter. The point A lies on L1, given that O equals to 5 root 10. Show that at A, the parameter lambda satisfies 81 lambda square plus 52 lambda minus 220 equals to 0. So what we're going to do is we're going to make the coordinate from the vector r, find its magnitude, and put it equal to 5 root 10 to create this equation. So firstly, OA is going to be 1 plus 8 lambda, 2 minus lambda, 5 plus 4 lambda. OA square equals to 5 root 10. So chords of OA, 1 plus 8 lambda squared plus 2 minus lambda squared plus 5 plus 4 lambda squared is the same as 5 root 10 being squared. Once again, if you go back, it says O equals to 5 root 10. So if you're squaring OA, we're squaring 5 root 10 as well. So when we expand the brackets, we're going to get 1 plus 16 lambda plus 64 lambda plus 2 minus 4 lambda plus lambda square plus 25 plus 40 lambda plus 16 lambda squared. And that equals to 250. Bring everything on one side, collect the like terms. So that's going to be 81 lambda squared plus 52 lambda minus 220 equals to 0. That's your answer. And hence show that one possible position vector for A is negative 15I plus 4j minus 3k, and then you have to find the other possible position vector for A. So for that, you have to find the value of lambda, and you'll have to factorize this quadratic equation. So 81 lambda squared plus 52 lambda minus 220 equals to 0. That's going to be 81 lambda squared plus 162 lambda minus 110 lambda minus 220 equals to 0. So 81 lambda bracket lambda plus 2 minus 110 bracket lambda plus 2. So lambda plus 2 bracket 81 lambda minus 110 equals to 0. So lambda equals to negative 2 and lambda equals to 110 over 81. So to find the position vector mentioned in the question, we're going to put lambda equals -2 in the R vector. So 1 plus 8 times -2, 2 minus -2, 5 plus 4 times -2. That's going to give us the same vector as given the question, which is -15i 4j minus 3k. That's your answer. For part 2, we'll substitute the other lambda value, which is 1 over 10, which is 110 divided by 81. So R equals to 1 plus 8 times 110 divided by 81. 2 minus 110 divided by 81. And then 5 plus 4 times 110 divided by 81. That gives us 961 over 81. So 52 over 81. And then lastly, 845 over 81. That's your other position vector. Then it's saying the line L2 is parallel to L1 and passes through O. Given that OA is -15i plus 4j minus 3k, point B lies on L2 where OB is 4 root 10. Find the area of triangle OAB, giving your answer to one decimal place. So if L1 and L2 are parallel, that means they share the same position vector. And OA is given as -15i plus 4j minus 3k. So to find the area of this triangle, we need the angle between, if we draw the triangle OAB, OAB. Right now we have the magnitude of OB, which is 4 root 10. And we have the magnitude of OA, which is 5 root 10. So which means we need this angle over here, because to find the area of the triangle, we need two lengths and the angle between them. So keeping that in mind, we can use the two vectors to find the angle. So position vector of OB is going to be the same as the position vector of L1, because L2 and L1 are parallel and point B lies on L2. And for the position vector of OA, that's already given, which is this. This is the position vector of OA and this is the position vector of OB. So let's use the cos formula to find the angle. So cos theta is going to be equal to the dot product divided by the product of the magnitudes of the two position vectors. So 15, 4, -3, and then 8, -1, 4. Always use position vectors in these formulas. So -15 squared plus 4 squared plus -3 squared times 8 squared plus -1 squared plus 4 squared. So for the dot product, what we get is -136. And for the denominator, we get 45 root 10. So theta is going to be cos inverse of this fraction, which is basically 0.9557. And that gives us a value of 0.299 radians. So now for the area, it's going to be 1 over 2 times 5 root 10 times 4 root 10 times the sine of 0.299. Plug this in the calculator and what you get is 29.4 units square. That is the area of the triangle OAB. Then the next question says the current X amps at time t seconds after switch is closed in a particular electric circuit is modeled by the equation dx by dt equals to k minus 3x, where k is the constant. Initially, there is zero current in the circuit. Solve the differential equation to find an equation in terms of k for the current in the circuit at time t seconds. Give your answer in the form of x equals to f of t. So to solve part A, we're going to integrate the equation. So A equals to dx over dt equals to k minus 3x. Integrate this. So that's going to give us dx over k minus 3x equals to the integral of dt. To integrate this, we have to bring the x to the other side. So it's going to be with dx and dt goes to the other side. Now when we integrate this, it's going to be negative 1 over 3 ln of k minus 3x equals to t plus c. Integral of dt is going to be t, and since there is no limit over here, so we add c, which is the constant. And over here, 1 over k minus 3x becomes ln k minus 3x, and we divide it by negative 3 because we differentiate the negative 3x as well. And that derivative comes in the denominator. So now we know that initially there is zero current in the circuit, so that means x equals to 0 and t equals to 0. So we substitute this to find the value of k. So that's going to be negative 1 over 3 ln k minus 3 times 0 equals to 0 plus c, which is negative 1 over 3 ln k equals to c. What we're going to do now is we're going to substitute the value of c back into this equation and then figure out the value of k. So negative 1 over 3 ln of k minus 3x equals to t minus 1 over 3 ln of k. So bring the ln on the same side. So negative 1 over 3 ln of k minus 3x plus 1 over 3 ln k equals to t. Negative ln of k minus 3x plus ln k equals to 3t. If we rewrite this as ln k minus ln of k minus 3x equals to 3t, we can write the ln as ln of k over k minus 3x equals to 3t. To get rid of the ln over here, we can add e on the right hand side. So it's going to be e to the power of 3t. Then I'm going to cross multiply. So it's going to be k times e to the power of 3t minus 3x times e to the power of 3t. Then it's k minus k times e to the power of 3t equals to negative 3x times e to the power of 3t. K minus k times e to the power of 3t divided by negative 3 times e to the power of 3t equals to x. So if we go back to the question, they just want us to write x as f of t. We can further simplify this by splitting it into two fractions, k over negative 3e to the power of 3t plus k times e to the power of 3t over 3e to the power of 3t. The e to the power of 3t cancel out over here. And we can write this as k times e to the power of negative 3t over negative 3 plus k over 3. So if we take k over 3 common, that becomes 1 minus e to the power of negative 3t equals to x. So this is your fully simplified version. Then it says, given that in the long term the current in the circuit approaches 7 amps, find the value of k. So if in the long term it approaches 7 amps, time can be anything. It's infinity because it's long term. So what we're going to do is we're going to assume that time is approaching infinity. If it's approaching infinity, that means the exponential function, which is e to the power of negative 3t, is also approaching 0. Which means 7, which is x, equals to k over 3 times 1 minus 0. Hence, 7 times 3 equals to k, and that's 21. Once again, since it's long term, that means time can be anything. We don't know, it's infinitely increasing. If it's infinitely increasing, that means exponential function is approaching 0. So when you replace e to the power of negative 3 over t with 0, what we get is 7 equals to k over 3 times 1 minus 0, and k equals to 21. Then it says, hence find the time in seconds it takes for the current to reach 5 amps, giving your answer to 2 significant figures. So for that, equation is x equals to now 21 over 3, k is 21, times 1 minus e to the power of negative 3t. So x is 5 now. So 5 equals to 21 over 3 equals to 1 minus e to the power of negative 3t. 21 divided by 3 is 7. So it's going to be 5 over 7. And then we're going to subtract 5 over 7 from 1, which gives us a value of 0.285. Then when we add ln over here and here, negative 3t comes down, ln e is 1. So this equals to ln 0.285. So t is going to be ln of 0.285 divided by negative 3, which gives us a value of 0.42 seconds. Yes, that's your answer. Then it says show that the binomial expansion of f of x is, then we have f of x equals to 8 minus 3x to the power 4 over 3, where x is between 0 and 8 over 3. We have to show that the binomial expansion of f of x in ascending powers of x up to including the term in x cube is a minus 8x plus x squared over 2 plus bx cubed plus so on, where a and b are constants to be found. So for this, we're going to use binomial expansion. So f of x is 8 minus 3x to the power of 4 over 3. We're going to take 8 to the power of 4 over 3 common outside so that the first digit is 1. So 8 to the power of 4 over 3, when you take that common outside, it becomes 1 minus 3 over 8x whole power 4 over 3. Now we're going to use binomial expansion on the bracket, and 8 to the power of 4 over 3 becomes 60. So to expand this, it's going to be 1 plus 4 over 3, which is n, times the b value, which is negative 3 over 8x, plus n times n minus 1, divided by 2 factorial times negative 3 over 8x squared. Then plus n times n minus 1 times n minus 2 over 3 factorial times negative 3 over 8x whole cube. We're going to stop at the term with x cubed because that's what the question is asking us. So let's simplify this. 16 times 1 minus x over 2 plus 1 over 32x squared, and then we get plus x cubed over 384. Now we expand the bracket. That's going to be 16 minus 8x plus x squared over 2 plus x cubed over 24. That's your expansion. Then it says use proof by contradiction to prove that the curve with equation y equals to 8 plus 8x minus 15 over 2x squared does not intersect the curve with equation y equals to a minus 8x plus x squared over 2 plus bx cubed, where x is between 0 and 8 over 3, where a and b are constants to be found in part A. So we already found the values of a and b. A is 16 and b is 1 over 24. So let's prove this now. So one equation is y equals to 8 plus 8x minus 15 over 2x squared. The other equation is y equals to 16 minus 8x plus 1 over 2x squared plus 1 over 24 x cubed. Put them equal to each other. The reason why we're putting them equal to each other because you're proving through contradiction. So we're going to do the opposite of what they're saying in the question. They're saying that they don't intersect, so we're going to show the intersection. Hence the contradiction. So let's write the equations down first. So that's going to be 8 minus 16 plus 8x plus 8x minus 15 over 2x squared minus 1 over 2x squared minus 1 over 24 x cubed equals to 0. So now we're going to collect the like terms and simplify it. So that's going to give us negative 8 plus 16x minus 8x squared minus x cubed over 24 equals to 0. So I'm going to multiply all of the terms by negative 1 to make x squared positive. So it's going to be 8x squared minus 16x plus 8 plus x cubed over 24. I'm going to focus on this right now. I'm going to take 8 common. So that's going to give me x squared minus 2x in the bracket. And I'm going to apply completing square form on this bracket. So to apply completing square form, what I get is 8 bracket x squared minus 2x plus 1 squared minus 1 squared plus 8 plus x cubed over 24 equals to 0. That's going to be 8 bracket x minus 1 squared minus 1 plus 8 plus x cubed over 24 equals to 0. Expand the bracket, so that's going to be 8x minus 1 squared minus 8 plus 8 plus x cubed over 24 equals to 0. Minus 8 plus 8 cancel out the 8. So it's 8 times x minus 1 squared plus x cubed over 24 equals 0. So the question said that we have to prove that they don't intersect. So if we notice, since we have the equation completing square form, we know that x equals to 1 is one of the values. So if we put x equals to 1 in the equation, so 8 times 1 minus 1 whole square, and then we have plus 1 cube over 24, and it's equal to 0. When you substitute this, we get 0 over here, but this is not 0, it's 1 over 24. So we can clearly see that it is not equal to 0, it's more than 0, because 1 over 24 is not equal to 0. Hence, 8x minus 1 whole square plus x cubed over 24 is greater than 0. If they were intersecting, it would be equal to 0. Both sides would be 0, which means 1 over 24 cube would also be 0, not 1 over 24. Which means the x cubed over 24 part would also be 0, not 1 over 24. But since one part is 0 and one part has a value greater than 0, when we add them, it is not equal to 0, which means they don't intersect. So hence, they don't intersect. That's your answer. Then it says the curve C shown in figure 3 has equation y equals to x to the power of negative 104 divided by root of 1 plus x times arctan root of x. The region R shown in figure 3 is bounded by C, the line with equation x equals to 3, and the x-axis and the line with equation x equals to 1 over 3. The region R is rotated through 360 degrees by the x-axis to form a solid using the substitution tan u equals to root x. Show that the volume V of the solid formed is given by k times the integral of 1 over u squared du from the limit of a to b, where k, a, and b are constants to be found. And then we have to use algebraic integration to find the value of v in simplest form. Okay, so let's start with the first part. We have this equation for y. We know that tan u equals to root x, and we have to use a substitution to integrate this and then find the equation for the volume. So let's begin with using tan u equals to root x. Okay, so the equation is in terms of x and arctan. We know that if we square both sides, that's going to get rid of the root over here. So it's going to be tan square u equals to x. That is one thing. Other thing we will do is that we will differentiate this equation. So when you differentiate this equation, derivative of tan is secant square. So secant square u times du by dx, because we're going to differentiate u with respect to x. And then the derivative of root x is going to be 1 over 2 times x to the power of negative 1 over 2. Since in the equations in terms of x and over here, the integral has du. So what we're going to do is we're going to make dx the subject over here and then substitute it with the du part. So what I mean is that we'll cross multiply 2 times secant square u times root x times du equals to dx. This is what we have. So when we create an equation for the volume is basically pi times the integral of y square times dx, and an arc is going to be from 1 over 3 to 3. Since we're rotating through 360 degrees about the x-axis, so we're going to square y. So that's pi with integral of y squared. So y is x to the power of negative 1 over 4 over root of 1 plus x times arc tan of root x, and all of this is being squared dx from 3 to 1 over 3. Let's further simplify this. The opposite. 1 over 3, 3, 1 over 3, 3. When you square the numerator, we get x to the power of negative 1 over 2. Square of root of 1 plus x is going to give us 1 plus x. And this becomes arc tan root x whole square. Now we're also going to replace the dx with root x to root x times secant square u du. Next, I'm going to simplify this. So x to the power of negative 1 over 2 times x to the power of positive 1 over 2 cancels it out. So it's 2 secant square u divided by 1 plus x times arc tan root x whole square du. Now we know that tan u equals to root x, so u would equal to arc tan of root x. So we can easily replace this with u. So 2 secant square u over here. 1 plus x equals to u squared. And about the 1 plus x over here, if root x equals to tan u, that would mean that, let me go back over here. Since we know over here that root x equals to tan u, so x would equal to tan square u. So we can replace the x with tan square u. This is x. So pi 1 over 3, 3, 2 secant square u over 1 plus tan square u times u square du. This is your equation. 1 plus tan square u equals to secant square u. So we're going to just substitute that over here. So 2 secant square u over secant square u times u square times du. So you can cancel out the secant square u. So that gives us pi from 1 over 3 to 3, we have 2 over u square du. So you can bring the 2 outside, so it's 2 pi outside. And then we have the integral of 1 over u square. And I think that's your answer. That's your answer to part A, because I just wanted to convert the volume into this form. So k times the integral of 1 over u square du. So k is 2 pi, and we have 1 over u square. Then it says, hence using algebraic integration, find the value v in simplest form. Now we have to integrate this to find the value of v, but we have to remember this as well, that 1 over 3 and 3 are values of x, not u. So we have to find the value of u. So we know u is arc tan of root x. So it's 1 over 3. U equals to pi over 6. And then when x is 3, u equals to pi over 3. So now for integration, it's going to be 2 pi integral from pi over 6 to pi over 3 of 1 over u square. These are your u values. Now we can integrate it properly. Don't make the mistake of using 1 over 3 and 3 because those are your x values, not your u values. So you have to be careful about this. So when you integrate this, we get negative 1 over u. We plug in the values of pi over 6 and pi over 3. So that's going to be negative 1 over pi over 3 minus negative 1 over pi over 6. That gives us a value of 6. So that's your volume. And with that, we're done with paper 4 for June 2024. If you have any questions or confusions, please leave a comment below and I'll help you out. If you understood everything, please like and subscribe, share this video with your friends, and don't forget to check out the other videos in this playlist.